For months, I've been lying here in my sunny bed in the mornings, watching what happens. Can't really see it. When cat hair gets tossed in the air. There's the source of the aerodynamic experiment. Say hi, Moonroof. She has nice, fine, short hair. And when I flick the hair, yeah, the lighting is an issue with this camera. Oh, there went one. It's actually a cluster. But the interesting thing is that some of the hairs spiral to the ground. And if they're not bilaterally symmetrical, they twirl down. If they're bent in a zigzag, that's what happens. If they're bent, however, in a shallow V, I wish I could get one. Right. That's a straight one. So if they're bent in a shallow V, they stay aloft a very, very long time. And when they drift laterally, they always stay with their tips upward, their central bend downward, and they drift. If they lie in a plane, the plane drifts always in a vertical orientation. So in other words, if they were a very short bird with no head and no tail, they would still face forward. Now, the interesting thing about this is they don't need a tail to face forward. And we think about the way airplanes are built these days. Generally, for long-distance gliding, they have very straight wings without much sweep to them. Let's see if we can keep doing this. Maybe we'll get one on screen. Yeah, it's lots of fur. It demonstrates what I'm watching, but it doesn't demonstrate what I'm seeing. Great camera for this. So I'll just continue to talk. And you can watch the cat. So even without a tail, these things face forward, as it were. The fighter aircraft, or aircraft that need maneuverability and to make quick turns, they have more, or that do that proceed very fast in one direction and need less drag. They want to trade off their drag for speed. They have swept back wings. But what we're seeing here is the effect of just a nice, gentle V-notch, or even a more severe V-notch, on the ability to stay in the air and remain oriented. They will rock a bit in a, let's see, they will rock a bit in a gust, if you will, a little puff of air, but they maintain their position. Any variation on that results in an unstable form. It falls out of the sky. The closest thing I can think of to this, the only airfoil I know of that's built that way is a hang glider, and even that's not right because it's swept backward. It's not swept upward. Right? This upward sweep, even though it does show up in sort of like jet aircraft, passenger aircraft, very slightly, tends to be it's almost minimized. It doesn't seem to be. It doesn't seem to have a lot of effect. It's not being counted on. And I'm really wondering what would happen if an airfoil was built that was very low profile, front to back. It was essentially built like like the flying wing in Raiders of the Lost Ark, but allowed its tips to go upward instead of backward? What if you didn't need a tail? What if you didn't need to have front to back length? Just because birds do this, well, bird's an organism. It evolved like other organisms. It has a front of its spinal cord where the sensory, most of the sensory gizmos are. It's got appendages, and it's got a butt. And you cover that with feathers, and you get something that wants to go through the air head first. But a piece of cat fur doesn't have a head. It doesn't have a butt. Right? And it stays in the air just fine if it's the right shape. And it has essentially no length. There's room here for investigation. Anyway, it's the 4th of February, or 4th of, yeah, forget that. It's the 4th of March, 2010, and that's Moonroof.